part 3 of chapter 7, we are continuing our discussion regarding the long-run growth in an economy. So if the way we discussed it in chapter 5, the growth in short run, which is called the business cycles, what may cause over the 30 years, 50 years, or 100 years, the growth take place? So what would be the essential reasons? In order to explain this, I would again illustrate the economy. The owners of the population is the owners of all factors of production. So this is like those 1,000 person, which we had it in our example. And from here, we know that the economy, the production of economy needs factors of production. Three major of them is the labor, capital, and other resources or natural resources. The natural resources are actually the natural endowments. How plentiful a certain, like Oman has oil, gas, other resources. Okay, so this is basically, we get it from nature, right? And the amount which we are picking and the flow of resources into our economy. And it's the population who owns it, be it a representative of the population, the government, or themselves, by exploration, we find new resources. And if we find new resources, then we can produce more and more. And the output, of course, is the real GDP. In terms of capital, if people are making savings, and the saving becomes investments, and investments are injected into the capital. And if you remember in national accounting, we said capital in time t is capital in time t minus 1 plus net investment. These are the new machines and equipments. And of course, there's some depreciation here also. The net investment is the gross investment after the depreciation. The depreciation are the replacement investment or the amount which for keeping the durable machines and equipments working. We need to do it. It's always some positive figures. And if you take that out from the gross investment, and if gross investment is bigger than the depreciation, we are going to basically grow capital stock. And if a capital stock is increasing, then the flow of which the energy we can drag, and actually the machines and equipments always should be mixed with capital per se is not producing anything. Always man force or materials, raw materials, processed materials to be used, and then we can make goods and services. So that's the nature of the capital. The capital itself is not producing. Some say that artificial intelligence is coming, and then the machines can do everything by themselves, but that's still like a science fiction. We think that even artificial intelligence needs a man behind its programming. But the labor is very important. Actually, this is the employed labor because we have labor unemployed, and here we have the labor force. So a fraction of the labor force is coming here. The remainder remains here as none in the labor force, non-labor force, inside here as the users. So these are the users, they are not productive. Older people or those who don't have no willing to work. Okay, so only a fraction, let's say 60% of the population who are willing to work, and this is a part which may or may not go loss. They are available, but the economy may or may not use it. So that is at the end of the day, the employed labor, that labor force, we said labor force is equal employed plus unemployed. This is the one which is flowing to the economy and generates the GDP. So our question is that, okay, how much the economy is growing depending on whether we are doing a right investment or doing enough exploration, or what is the unemployment rate, then the actual GDP is changing. But imagine that we are assuming that the unemployed labor is, let's say, exactly equal natural rate of unemployment, which was frictional plus structural unemployment, approximately 5%. And we have 95% in workplace. And we are doing also good use of capital, good use of resources. Hence, instead of this actual GDP, we are producing what is called potential GDP. Potential. At the end of the day, we know that output is going to be a function of the amount of labor, of course, employed labor, and amount of capital, stock, and resources. So the more of them, the more of this. There is a one-to-one relationship. If these increase, then GDP is increasing. If we are getting the actual unemployment rate, then we are getting this one. If we put here actually potential level of employed, 90% of, approximately 90% of labor force, then we are getting the potential level of output. Potential level of output is equal, here we have normal rate of unemployment. We have no loss in the labor force. And what is considered as unemployed, that is what is useful. It is normal to have it. Okay, so this always equal? This is output. Actual output is always equal the potential level of output. The answer is of course not. We might have actually produced more or produce less than potential level of output. It depends on the cyclical unemployment. The cyclical unemployment was U minus U star. If the cyclical unemployment is negative, it means that we are hiring more than natural unemployment rate. Hence, we may produce more than what potentially. This is exactly when cyclical unemployment is 0. This is when cyclical unemployment is very large and big. Let's say natural rate of unemployment is 5% and actual unemployment 5%, and actual unemployment rate is 20%. So here we have 15% unemployment, so the actual unemployment falls far below what we potentially can produce. So this is the potential production. If you want to draw it in the long run production, it's going to look like this. This is time, and this is potential level of output. Okay, potential level of output, we know that it's constantly growing, smoothly growing from, if we have initially, and here we are in time t, we reach to yt. There's a smooth growth because there is no basically ups and downs, whereas the actual, if I put the let me show it the different color. If this is the actual output may go fast, or so this is what we explained in chapter 5. So we might have actually business cycles. So these are short run, and the black line here is showing the long run growth. Okay, so this is what macroeconomics is trying to explain actually. So if I go back to our output growth in the long run is when, the growth rate of output of the entire economy, and per capita output growth rate of output per person, and productivity growth is the output, the growth rate per workers. So this is very important. If I come back here, we have multi-input and multi-output. This is also so many factors, so many goods and services. If you make a GDP, we have made a quantity index weighted average of all things which are produced. So a productivity is that if we are using less input and get more output, economy is more productive. So the ratio of Y over labor, it's called labor productivity. Why? It means the output per number of workers, or per hours of workers put effort. Okay, so if we can produce with fewer number of workers, it means that we are able, or how much every workers generate GDP. Every 1,000 workers generate GDP. So this is called productivity. We can have the capital productivity, these are partial factor productivities, and or resource productivity. This is very important. We can draw it. And another thing which we can calculate, the ratio of these ones against the capital. So the capital per worker, K over L. How much machines ratio of the ratio of capital over workers. These are shown in these two charts. This is showing the output per worker. So you see that in the US economy, a worker could produce about, every worker, about some $20 in constant term, every hour of workforce could generate $20 worth of output. Okay, and this was in 1952. Now imagine that every worker can generate nearly $100 $8 worth of output in real terms, physical output. So it shows that our worker over time have become more and more productive. The other diagram is showing the capital per worker, the K over L. So in 1952, for every worker there was about 40 machines. But now for every workers is about 100 in constant dollars worth of stock of machines and equipment. So it means that it is because of the capital mix, capital labor mix, which economy has been able to produce more and more. So what is not explained in the book is that what would be the long run growth rate? Long run growth rate, let me call it long run G, is how much on average we can go from point 0 to point T. So it's basically I'm wondering how we can measure this. It is YT is growing with fixed let me use now R. Okay, R. Long run growth as R multiplied by the number of the years, which is T years. So you can basically now calculate R is a natural logarithm of the ratio of YT over Y0 and divided by the number of the years. So this is basically, I solve it for R and this will be given. This formula is, you may say that where did you get this from? You may write it in a discrete way. YT is the Y0. It's what in Arabic we call it rep murakkab. It's 1 plus R to the power T. If you use this formula, then the R is gonna be the teeth root of the ratio which I used in the other formula, and then you take the 1 out of it. So this is basically doesn't matter whether you are using this formula or this formula, but this is the mostly used formula. It's showing that on average how much we are growing. And so if you are in this year, let's say in year N, you can easily say that I know Y0 and Y in year N is going to be Y0 e to the power and this R again, which it's going to be fixed, R fixed multiplied by N this time. So I can calculate it here, I can calculate it here for every, and it's a smooth growth. That's why we call it long run growth. Long run growth. But the actual growth, that G, was the YT minus 1 divided by YT minus 1 multiplied by 100. This is sometimes going faster, sometimes going slower. So we are having a difference. Here we have Y, here we have Y star. Y minus Y star is called the output gap. So when the output gap is 0, we have no problem in the economy, because this is equivalent of the U is also equal U star, or unemployment rate is natural unemployment rate, and we are producing exactly what potentially economy can produce. But if Y minus Y star is bigger than 0, we are here, Y minus Y star is bigger than 0, the economy is in expansion, we have expansionary gap. And if Y minus Y star is negative, we are in more trouble. We are actually producing less than what potentially we could produce. We are in contractionary or recessionary gap. So the long run growth and short run growth may deviate from one another. Another things which we are going to explain in macroeconomics is this one. So looking ahead, we need some model to be able to explain why we are deviating from the long run growth of the economy, why the short run business cycles takes place, and how we are able to associate these deviations or business cycles to our unemployment rate, inflation, and the GDP growth. So all those three concerns, which in every chapter I name it in the beginning, these three major concerns, we are after to say why. So far we did not answer the why question. For why questions, we need a model. And that model, we start from a very simple model. It's called basic Keynesian model. And then we are making it more and more advanced to answer why there is sometimes the output growth is negative or positive, why there are high unemployment or low unemployment, why there's high inflation or deflation, and etc., etc. So this is basically the end of chapter 7, and next video would be the start of part 3, which is the macroeconomic model. Thank you.